Ever bombed a system design interview? I just turned a URL shortener into a career shortener. See if you can catch my mistakes and watch the 3-step fix at the end.
System design interview. Design a URL shortening service.
Given a URL HTTP in the backend, I'd like to store a hash map that maps this URL, say AAA, to our shortened form. I should keep the shortened as the key, and then the original as the long one. So when it click on the short, we will return the AAA and then request the original website. Any questions so far?
No, all good.
So to handle scalability, if multiple users request our hash map, we want to have multiple replicas. We will have a load balancer so that different users, when their request come, both say request A, the balancer can dispatch the request to different databases. So each database can publish its metrics to the load balancer such that the load balancer will know their load.
Cool. So yeah, I see that you're talking about a retrieval situation. Can you describe to me what happens on the back end when a user gives you a long URL and asks you to shorten it?
Oh, yes, great question. In the creation of the short URL, the user sent this long URL of BBB. Then we will first create an entry in the hash map. We want to find a key that is not present in the current keys.
Can you elaborate a little bit on how you are going to create a new key?
Great question. So I will define a function and new key. Say the shortened URL has a max length of 3. Loop through all the combinations of using of the length 3 string. So we can have A, AAA, BBB, CCC. So from this pool of shortened URL keys, we will choose one that is not registered. Do you want me to elaborate on any of this?
No, all good. Looks like if we're looping through some list every time, there's something there to be optimized, but we can talk about it later. Please continue on with what happens after you've created the new key.
Store it in the hash map with the key as the new URL, the value to be the original URL. So this is done on one replica, and we need to broadcast it, whether synchronous or asynchronously, to the other replicas as well, so that each of them has the same updated hash table.
All right. Yeah. Suppose you encounter a system failure, and not all of your databases are in sync. How would you recover from that?
Oh, good question. So one replica crashed, and how can we recover this replica?
Sure, that's one situation.
I can. So let's say one replica crashed. How to, and when it's back online, it missed say 30 minutes of transactions. So I would let replica 2 to start broadcasting replica 2's information to replica 3 to fill in the records. So in this design, let's say we have a central server called metadata server. We'll know each of the replica contains what keys. So this metadata server will tell replica 1 and 2 to send their data to 3, if that makes sense. So maybe one has partial data and two has the other shards. So both of them need to send.
Sounds good. If we're trying to scale the system up, like more concrete principles would you use to be able to support multiple lookups?
Yeah, good question. I would use a Kubernetes cluster. We will wrap each database into a pod, and each node can have replica 1, replica 2. So now if we want to scale up, we can add a pod within a node. And if we want to further scale up, we can add a new node. So in this way, if we don't need to scale up too much, we can just add a virtual replica instead of a hardware instance, if that makes sense.
What is the correct approach? Simple 3 steps. First, the front end. When a users create a URL, it will send this long URL AAA to the backend. What the backend does, it will use a hash function to create a shortened URL and make sure it doesn't overlap with any existing keys in the database. And step 3 is to register this short URL and the long URL in this database backend. All system design mostly consists of those 3 components. Please leave any questions in the comments, and thank you for watching.